Hi everyone, this is Robin here, and in this video we'll see the solution of the problem C from Codeforces Education round 156. So first we can try to understand the problem statement here. So the problem statement is that we are given a string called S1, and let's say the length of the string is n. Length is n. Now we have to create total of n strings. One string we are given, so we have to create n minus 1 more string from this S1. So we'll call those S2 dot Sn. Now the operation that we have to do is, let's say we want to get S2. So we have to do the operation on S1. We will remove a character from S1 so that S2 is lexicographically smallest. Let's see an example. Let's say we have a CAB. Let's say S1 equals to CAB. Now we have to remove a character from this string so that S2 is the lexicographically smallest string. So we can try three cases here. Let's say I remove C, then we will be left with AB. Or I remove A, then we'll be left with CB. Or third, I remove B, then we'll be left with CA. So out of these three strings, this is the smallest. So S2 will be equals to AB. Similarly, we have to create S3 and then until we reach a string of length 1. We have to do these operations. Now, we are also given a position in the problem. So this position we'll have to use somehow. So in the problem statement, we have to create a bigger string called as, which is the sum of S1 plus S2 plus S3 dot Sn. Now in this new string, I have to find the character at this position called pose and print on the screen. So let's take an example here. So let's say we are given S1 equals to CAB. Then S2 will become AB, right? We'll remove C. And S3 will become A. We will remove B. So the new string will become CAB plus AB plus A, which is equal to CAB, AB, A. And let's say the position given in problem is equals to 4. So we'll go through this string. So this is position 1, this is position 2, this is 3, this is 4. So the output for this problem will be A, the character present at 4th position. Answer will be A. Yeah, so this is the problem statement. Now let's see how we can solve this problem. So first we can try to think about the brute force solution, like where we will do the exact operations. Like we are given S1, we will create S2, we will create S3 dot Sn, and then we will merge these strings and print the character at 4th position. But there is a problem in this approach. So this is the brute force solution, brute. So the problem with this approach is the time complexity as well as the space complexity. So the time complexity will be O of n square, because each time we want to create a lexicographically smaller string from S1 or from the previous string, we want to iterate, in the worst case we want to iterate over all the characters to create that string. Similarly, we will have to create this type of string n times, and at first the length will be n, then n minus 1, it will reach to 1, which is equal to O of n square complexity, right? So the time limit itself won't allow this. And we can also see the space complexity, that we will have to store this string, then this also in the memory, and this will also be same as O of n square. Yeah, so this is not a good solution. Now let's try to find a better solution. Let's say we know the string in which the position is occur. For example, let's say there is a string called sk, and we know that the position will occur in this string. So what we can do is, to find the answer, we can decrease all this length from position, whatever is before sk, and then we will print the character in this string from that new position. So let's say there is a position 1 called position minus sum of S1 up to sk minus 1. So this is the new position. So the answer will be sk of position 1, right? So now the two new problems here are, first is how to find k, right? And second is how to find sk. So let's try to solve these two new problems. So first, like how to find k. What we can do is, so we know that the length of first string is n, and then length of second string is n minus 1, length of third string is n minus 2, right? So we will try to see, like, we'll go from left to right, and we'll maintain a global current length. Like at first iteration it will be equal to n, then at next iteration it will be equal to n plus n minus 1. Similarly, like we can go until we find k. So how do we find this k? We will see that if position is greater than equals to, or if position is less than equals to current length, right? Then we will know that whatever is the current iteration, position will lie in that string, right? So the first iteration, like this is the first iteration, this is the second, this is third. Let's say here the current length becomes greater than equals to position. So we can say that this iteration, at this iteration k will be equals to this string, right? So this is how we find k. So this is the linear search approach. But we can also do this with binary search, which I have done in the code. But linear search is sufficient in this case. Yeah. Now let's see how we can find sk. What will be the value of this string, right? So we can see this with an example. Let's say I have a string C A B B B A B C D E F. I have S1 something like this, right? Now we'll try to see how to find S2. So at first we need to know how we can find the smallest lexicographical string after removing a character, right? And so let's say we have some increasing characters, non-decreasing, like this, and suddenly we get some small character, right? Then this means that if we remove this character, so the next string will be the smallest, lexicographically smallest string, right? If we remove any other character, let's say from here or here, then that won't be smaller than this one if we remove this one, right? So this is one way, like we will go from left to right, and whenever we find some character which is greater than next character, then we need to remove this character, right? And second is, let's say we didn't find any character which is greater than next character. So it will go like this, and we'll reach at the end, right? So in this case, we need to remove the last character, because that will give us the smallest lexicographical string. Okay, so this is how we find the smallest lexicographical string. So we had this example, right? Now we have to like create a solution so that we can find sk, and that also we need to find it optimally, right? So what we'll do is, we can maintain a, let's say, a bag. We have a bag here, and we'll put in the indices in there. Let's say we have S1. For S2, let's say we need to remove some index X, so we'll put X in this bag. And for, let's say, S3, we need to remove some index Y, then we'll put Y in this bag, right? So finally we will somehow reach sk. So for sk, we know that we have removed these indices. So what we can do is, we will traverse over S1, and whenever we find any of these indices, we won't consider that for our answer for sk, right? So this is how we can find sk. Now let's see what we can do to get these indices x, y, etc. So we have S1 like this, C A B B A B C D E A, like this, right? So first Like we will start from here. We will see that this is greater than this. So we will remove this one. So our bag will contain 0. Then this will come here. Then we'll remove, like we'll go from left to right and find the first index which is greater than the next one. So we come here. Now we will remove this one. So it is at position, like this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this we have. So we will put 4. So this also removed, right? Now we don't have to move to the next index in this case, because the previous index is already greater than this one. So we can move to a previous index now. Now we'll see that this is greater than A. So we'll remove B and we'll put 3. And now we'll move this index to 2. Now we'll again see for the next string that this is greater than this. So we'll remove B and put 2 in our bag. So this bag is actually a set in C++. Yeah. Now let's say we reach some position so that we are at the first index and this is greater than, these are all removed already, and this is greater than this one. So we need to remove this, right? But we can't move backward in this case now. So what we will do is we will move forward instead. So we'll remove this and we'll go to the next one like this. So if we have a previous element left in the string, we will move backward, otherwise we will move forward. Okay. And let's say we didn't find any index and we reached to the end. So we didn't find any index which is greater than the next one and we reached to the end. In this case, we should remove the end index. So this is how the algorithm will work. We'll put, whenever we find some index, we will put that in the bag. Now, there is one problem in this approach, and that's that it's a little slower. Why it is slower? Let's say I move backward here, and again I move backwards, then again here, right? Then I need to traverse all these characters again to see if I find some character which is like greater than the next one. So it will it's like an O(n) square approach again, right? For each new string, we want to traverse the string to find the index which we have to remove. So how we can optimize this? So for this, we can think of an linked list like approach. So we will maintain 2 arrays. One will be named next and one will be named previous, right? So in next we will store like what is the immediate next index which is not deleted yet. So initially, like for 0 we will have 1, for 1 we will have 2, for 2 we will have 3. Let's say the length is 5. So this is 0, this is 1, this is 2. For 3 we will have 4, and for 4 we will store -1 because there is no next index. And for previous array we will have something like for 0 we will have -1 because there is nothing index, there is no index before the 0, 1. And then we'll have, for 1 we'll have 0, for 2 we'll have 1, for 3 we'll have 2, and for 4 we'll have 3. So this is how the next and previous array will look like initially. And then we have this string, right? C, A, B, 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 A, B, C, D, E, F. So what we will do is we will traverse k times. We already have k. So we'll go from 0 to k minus 1. So this we will traverse k minus 1 times actually, because we want to do this operation k minus 1 times so that we can have sk, right? Because let's say if I do the operation 1 time, then I will have s2 because s1 I already have, right? So this we get after 1 operation. So sk we will get after k minus 1 operations, right? Now I'm at this position first. So I see that this is greater than a. So I will delete this character and I will put it into my set. It will have 0. And then I move my index to this one. Also, when I delete something, I should change my next and previous arrays. So now the previous will change, right? Because one index doesn't have any previous character. So, so we will replace 0 with -1 here. We'll go here. We'll see that this is less than b. We go to next index, then next, then next, then next. We go some. So at when we reach b here, we see that this is greater than a. So we will delete this, and this is at position 0, 1, 2, 3, 4. So we will put 4 in our set, and we will change the previous and next. So next of 3 will be 5 and previous of 5 will be 3, and we will delete 4. So whenever we want to move to next index, we should see the next array, and whenever we want to move to the previous index, we should see the previous array. So that's how we can like save the iterations here. We don't have to iterate over these many indices again and again. So we will do we'll keep doing like this until we like complete the for loop of k minus 1 times, and we will have our set containing all the indices which are deleted. Now we can like traverse over S1, and we will like ignore all these indices which are in this set, and consider the indices which are not in this set, and like find the character at position 1 which we had found earlier, right? So this is the approach for problem C. Now I will walk you through the code that I had wrote. So first like this is the length of the string n, and I find k using the binary search, and then like I find no position, I have overwrite the previous position, and then I create a set. It is called covered, so it will contain all the covered indices. I create 2 vectors called next and previous, and then I have this while loop. So this is to find the index where the character is greater than the next character, and it has a has ended boolean which denotes that the string has not ended. If the string has ended, then we need to delete the last characters only. If the string has not ended, we like put the index in the covered set, and we change the previous and next of the previous index and next index, and we move the index to either previous or next based on like whether there is previous index or not. And let's say if the string had ended, so in that case we simply put the index and we move to the previous index. So this is how we can get our covered set. After we get the set, we iterate over the S1 string, and we see that covered, whenever covered has some index, we ignore it. Otherwise, we decrease our position by 1. If the position ever becomes 0, we print that character. Yeah, so this is the code. So that's it, guys. I hope you like this video, and if you like this video, please subscribe to this channel so you can get more such videos. Thank you for watching.